Buddy, this is Miss Piekarski. I'm going over the review for the test that's on Wednesday this week, and it's going to be over your sequences and your series for arithmetic and geometric sequences. And there's only 15 questions on it, and each question only has one part, but several of the questions are all based on the same scenario. So let's look at the first set of questions. The first thing is we have the pattern in this diagram, and if you can see, you're adding more shapes to it with each successive one. And the scenario is Miss Piekarski's son, Briggs, starts making a pattern with a box of toothpicks. He created a pattern with the toothpicks as shown. So here's his pattern. Okay, the number of toothpicks used for each phase of the pattern creates a sequence, and it just asks you to list the first 5 terms of the sequence. So with this, each of these lines is a separate toothpick, so you count all the lines. And with the first phase of the sequence, you have, let's see, 3, 6, 9, 12. Okay, so the first phase you have 12. And then the second one, you have, let's see, if you just count the triangles, you have 1, 2, 3, 4, 5, 6 triangles. So 6 times 3 is 18, plus this center strip, so that's 19. Okay, so that's the second one. And then the third one, you have, let's see, it looks like how much extra are we adding each time? So let's see, if we had 12 and then 19, we would be adding, what, 7 each time? So if we counted all these, let's count the triangles first. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3 is 24, 25, 26. Let's see if we're still adding 7. So, yep. So if you do 19 plus 7, you get 26. So you can either, because you have the diagram, you can either count all these or else figure out what the common difference is. And in this case, we're adding 7 each time. So the next one would be 33, and then the final one would be 40. So if you can figure out the common difference or common ratio, depending on if it's arithmetic or geometric, then, to find the extra, these terms down here, just use your ratio or the difference. Okay, in this case, we had a common difference. And then the next question is the sequence arithmetic or geometric? The correct answer, or neither. The correct answer is arithmetic, and we know that because we're adding each time, so we have a common difference, which means it's arithmetic. Okay, and then express a sub n, the number of toothpicks used for the nth phase recursively. So if you recall, you have to have your a sub 1, and in this case, our a sub 1 was 12. And then to find a sub n, you just take your common, hold on, let me get rid of this. So you have a sub n equals the previous term, which is a sub n minus 1, plus my common difference, which is 7. And then here it says express a sub n, the number of toothpicks used for the nth phase explicitly. So this is the recursive formula now explicitly. So for the explicit formula, I'm just going to delete this so you can see it. We have the first term plus the common difference of 7 times n minus 1. And then if we wanted to, we can go ahead and simplify this to 7n plus 5. Make sure you know how to set it up like this or like this, because this is going to be a multiple choice test, and if you only know this method here, but your options are the simplified version of the equation, then you would have to know how to simplify it. But, so make sure you know how to do both of those. All right, next we have, okay, same kind of pattern, but this time the last question. After Briggs created the 5th phase of the pattern, his older sister Johanna knocked all the toothpicks on the floor. There should be a space right there. Knocked all the toothpicks on the floor. How many toothpicks did the kids have to pick up? So what we're looking for is the total amount. So with this, you can use your explicit formula here, and you can plug it in. Let me get rid of this. Okay, notice they did not say find the answer using sigma notation or using the series formula. So you can do either one. If you want to do the sigma notation, you have it here, and you have the j equals 1. I picked j just because. And then I use my explicit formula here, right here, and then because I'm looking for the 15th phase, the 15 goes here. And you plug it all into your calculator and you get 915 toothpicks. Okay, if you've forgotten how to do this and you want to use a series formula, then you would do the n, which is 15 divided by 2, times your first term plus your last term. Now to find the last term, you would have to plug in a 15 here for n and solve it, and you could plug that all into your calculator and you get 115. Either way, whether you use the sigma notation or the series formula, both of those processes should give you 915. All right, next scenario. A new teacher earns $41,000 during his first year of work and receives a 3% raise each year. Set up the sigma notation to determine the total amount earned by this employee over the first 5 years of teaching. Okay, so there's several parts of this. You have this part. Hopefully you guys remember how to do that. Just pick any letter, and in this case I had picked an n equals 1, and then we want for the first 5 years, so right here you would have a 5, and then here it's going to be a geometric sequence because we're getting a raise, so this would be your first term, the 41,000, and then your rate, most people want to just say it's 0.03, but remember if we want the percentage increase and the base pay, it's going to be 1.03, or just 1 plus whatever the percentage increase is each year. Okay, and then right here I have a lot of students messing this part up. Okay, here once we figure out the rate, then it's just n minus 1. I have several students that will go ahead and put the 5 that's supposed to be up here, they put it down here, and then it doesn't work. They get the wrong answer. Okay, make sure you put that 5 up here. Okay, so for this question, you don't even have to solve it. You just need to figure out how to set it up with the sigma notation. And then down here, set up the series formula to determine the total amount earned by the employee over the first 5 years of teaching. So make sure you know the geometric series formula. So with that, you need to have your first term, your a sub 1 goes here, and then you have 1 minus your rate, and our rate is 1.03, and then 1.03 is raised to the 5th power. Make sure that 5 is right here. I have a lot of students that want to put the 5 out here. That's the wrong place for it. The 5 needs to be attached to the rate there, okay? And then you have to divide by 1 minus your rate, your 1.03. Okay, and then finally, what is the total amount earned by this employee over the first 5 years? Okay, you can use either one of these formulas, plug it into your calculator, and find the answer. And that's the answer that we get right here. Okay, if you want, you know what, let me go ahead and plug this into the calculator, and I will show you what I was talking about when I said that a lot of people put the wrong information here. Okay, so let's do sigma notation. And let's say, this time I'm going to pick C just because that's the closest letter to my finger at the time. 41,000 goes here times 1.03 raised to the power of, so it should be C minus 1 because I used a C down here. And then up here is where I put the 5. Okay, so most of my students are putting the 5 down here. Now you'll still get an answer here, but it's not the correct answer. Okay, so to set it up correctly in the calculator, this should be your variable, push enter, and then you get the right answer. Okay, so either case, whether you do the series formula or the sigma notation, you should get the right answer. Okay, let's see, what else do I have? All right, here's another one. Archimedes used a pattern of squares as shown. Assuming the pattern continued to infinity, what would be the sum of the areas of these squares if the areas of the largest square were 13%? Okay, so because we're doing the infinite sequence, or because they want us to add up all the terms from the first term to the infinite term, I'm going to assume this is a infinite geometric series, and with that in mind, let's go ahead and figure out what our common ratio is. Okay, so notice we have a box here. Whoops, those were supposed to be straight lines. Just pretend they're straight lines, okay? Let me see if I can make them. Oh man, it is really hard to draw a straight line with this mouse. Okay, let's say we divide this box into four sections, four equal sections. Pretend these are straight lines. It will be equal sections. Then the ratio, so let's say my first term was 13. To find the second term, I would multiply 13 by 1/4 because this box here is 1/4 the size of the bigger box. So your second term is 13 times 1/4. And then your next one, notice you are also have this box is 1/4 the size of this box. Okay, so your common ratio here, your R value, is just 1/4. Okay, now that we know that our R is, the absolute value of R is less than 1, and we know that it's a geometric sequence because I have an R value, then I can use the infinite geometric series formula. And with that, let me go ahead and just get rid of this whole thing, delete that. Okay, when you're using the infinite geometric series formula, the way to set it up, whoops, I forgot to convert it back to the pen. Your first term goes in your numerator, and then in the denominator you have 1 minus your rate, and so we said this, our rate here was 1/4, and then you just plug it into the calculator, and this is your answer. Okay, so hopefully you guys are good with this one. Hopefully you understand that when you have a box like this, and then a box a fourth of the size, then your rate is 1/4. Okay. All right, let's move on. Which of the following sequences will converge? This is kind of a refresher to your geometric. It has to be geometric. I'm going to do a parenthesis or a period there. That's geometric, and the R value has to be less than 1. It can be a negative R value as long as it's less than 1. All right, so I'm looking at this, and I'm seeing that it is geometric because I'm dividing each term by 2, but I have a lot of people say that since I divide by 2 that the R value is 2. It's not 2. Remember, with geometric sequences, you're always multiplying. So if you're dividing by some number, then what you're doing is you're multiplying by 1 divided by whatever that number is. So for this case, my R value is 1/2, and it is geometric, so this one will converge. This one here, if you look, you're increasing each time, so you could automatically, without even figuring out the R value, you could say, no, that's not going to converge. That's going to keep on increasing by a constant rate or a common difference of some sort. Now let's look at this one. Do we have a geometric sequence or arithmetic sequence? Okay, if you look, what we have is an arithmetic sequence because we're subtracting by, looks like subtracting by 5 each time. So that's arithmetic. Well, arithmetic sequences don't converge. It will keep on subtracting into the negatives. And then this one again is increasing. You are increasing. We are, let's see. It looks like this is also arithmetic, and this time we're just increasing by 5 each time. We're adding 5. So it's an arithmetic sequence, so that one is also not going to converge. So the only one that will converge on this one is A. And I need to hurry because the bell's going to ring soon. All right, so now this one, give the arithmetic sequence, write an expression for A sub n recursively. Remember, with the recursive formulas, you have to have your A sub 1. So our A sub 1 is 25. And then when you set up the recursive formula, it's A sub n equals your previous term, A sub n minus 1, plus your common difference. In this case, we are subtracting by 3 each time, so it would be minus 3. Okay, and then we need to figure out, write the expression explicitly. So you have your a sub 1 minus your common difference of negative 3 times n minus 1. Okay, so that's just the recursive formula. And then let's look at this one, next one. Oh, sorry, hold on. Whoa, I don't want to do that. So back up here. This is your explicit formula. This is the recursive formula. And notice it tells you here that it is arithmetic, so that's a nice thing. Now we have geometric sequences. It looks like we're multiplying by 2 each time. And again, we need to know our first term. And in this case, our first term is 3, and then our common ratio is 2. And then we multiply it by the previous term. And then again, same sequence. It's still the same sequence, so our a sub 1 is still 3, and our ratio is still 2, and we just plug it into the explicit form. Okay? Hopefully you guys are getting better at converting from explicit form to recursive form. And let's see, I think that's it. Yep, that's it. Alrighty, see you tomorrow. We will review this in class, and then you can watch it for homework as well. Alright, see you later, alligators.